Okay, so chapter 2, the name of it, you don't have to turn to this page, but the name of it is called Reasoning and Proofs. You may have heard from people in the past, or people you've talked to who have taken this class, that you have to prove things, and a lot of people don't like them. Too bad, gotta do them. We're gonna start today, though, with things that are not proofs, and it's gonna feel like, well, by the way, there are 6 sections. We're gonna skip section 2.2, so there are 5 sections we're gonna do. It means you don't have a huge amount of time to get this chapter 1 test made up if you intend to, so get started soon if you intend to do that. Okay, section 2.1 is called Conditional Statements, and it's gonna feel like your English class today. And you're gonna do, all of your answers that you do are going to be written out clear across your page, so you may want to change what you just did to your paper. Only because it's, your statements are they're gonna be sentences. It's gonna be like English. We're going to talk about different aspects of the words, and what they mean, and how to interpret them, and how to write them in different ways. It's kind of a strange thing. It's called conditional statements, and a lot of people call this section if-then statements. And I'm gonna put a strange little statement on the board, a conditional statement, and we're going to talk a lot about it and its pieces and parts, and how you pull it apart, and how you make a geometric conclusion about things. It's going to seem kind of dumb at first. Here's the statement. If it is raining, then the streets are wet. Okay, we're going to pull this apart in a whole bunch of different ways. We're going to turn it around. We're going to rewrite it in different ways and funny ways and stuff like that. And then we're going to apply it to some other statements. This is called a conditional statement because there are 2 main parts. This word if right here tells you it's going to be a conditional statement. Sometimes conditional statements don't have an if in it. And you're going to get some practice on taking those that don't have an if in it and putting if in it where it goes so it says the same thing. It's followed, if there is an if, then it's followed by a then somewhere along the way. And all of this stuff between here and there is called the hypothesis. And everything behind the word them is called the conclusion. I'm going to do an awful lot of talking about this stuff. And if you don't understand something along the way, or your mind drifts and you need to get back to where we were so you can focus on what's going on, let me know. Because there's a lot to all of this.
So we if and then mean a conditional statement.
I'm sorry?
The if and then mean a conditional.
Yes. And what I was saying before is some conditional statements don't have an if and a then in it, but they're still conditional because you could put if in and then it has the same meaning. You're going to practice doing that in some cases. If you would like, when they ask you to identify the hypothesis and conclusion, you can just, and they'll do that, you can just write H colon and you can write C colon if you would like. That was a funny joke, actually. What happens if a piano falls on you? You be flat. Okay. All right. All right. Anyway, hypothesis. You can just write H colon, and if it says here's in a statement, it'll say write the hypothesis and conclusion for this conditional. And so you would write H colon, and you would write it is raining. You do not write the word if with it. If tells you that what follows will be the hypothesis, but that is not the hypothesis. It just tells you it's coming up. And the streets are wet is the conclusion because it follows on the heels of the word then. So do not include the words if and then when you're writing these things. So you can write H colon, C colon, and you have to actually write out the words that are the hypothesis and the conclusion of these conditionals. That will be the start of your assignment. Get practice doing that. Okay, we'll come back to more of this in just a minute. Let's practice what we've learned so far. It says in example 1, use red to identify the hypothesis and blue to identify the conclusion. Maybe red and blue. Okay, doesn't matter. It says, then rewrite the conditional statement in if-then form. You don't have to use red and blue. Well, you can use H and C colon. You can write it out in regular graphite, which is what you write. And this is the statement. All birds have feathers. Notice there's no if or then in there. It's still a conditional statement. And the way you would change it to a conditional with an if and a then in it is you would say, if an animal is a bird, then it has feathers. You know what I mean? Then you would identify the hypothesis and conclusion, and he left it, the author of the book left it in the exact same words it was written. All birds. That means if it's a bird, all birds include that. So you would say all birds are the hypothesis, and notice, remember I told you the other day the verbs of be, and as always, were being, be being, been, has had. Well, have is one of them, and you see it right there. Wherever you see the verb, that's going to be the break between the conclusion and the hypothesis if there is no word then. So, all birds, hypothesis, have feathers, conclusion. Got it? And you could write it in if-then form if required. If it's a bird, then it has feathers. B part. You're in Texas if you're in Houston. Notice that the if is inside the words, not at the beginning, but there is a word if. What follows on the heels of if is the conclusion. So notice in the blue here, which you're supposed to write, the hypothesis. Sorry. Following the word if is the hypothesis. And so we find if in the middle of the words here, and so the hypothesis is you are in Houston. That's why it's red. Because it follows on the heels of the word if. The conclusion is you are in Texas. See how it got reversed? Because the if showed up down the line ways. Doesn't always come at the beginning, so watch for it. Okay? I want you to look at the monitoring progress, number 1. It says all 30-degree angles are acute angles. Then you name the hypothesis. Yeah.
If it's a 30-degree angle, then it is an acute angle.
Okay, that you just wrote in if-then form, which is fine. Now, having stated it that way or not stated it that way, it's still an if-then form. It's still a conditional statement. Can anybody tell me the hypothesis of this statement as it's written? Yes.
All 30-degree angles
Good. Conclusion?
are acute angles.
There you go. Okay. So there was no if and then, but it was separated by a verb, are, and that's where the hypothesis is separated from the conclusion. Look at number 2. 2x plus 7 equals 1 because x equals negative 3. That's strange. How are you going to rewrite that one? Can anybody identify the hypothesis without putting it in if-then form?
2x plus 9 equals 1.
The because is kind of like the if in the thing about Houston and Texas. X equals negative 3 is the hypothesis. The conclusion is that 2x plus 7 equals 1. It's because x equals negative 3. So we're saying, if x equals negative 3, then this statement is true. So it got reversed. Because and if, they got put in different places. So you can run into some strange things. Okay. The next thing we're going to talk about, this is called the conditional. There's a way to rewrite this, and it's called the negation. So this is the conditional statement. Now we're going to write the negation. The negation is if you make each of these opposite. We negate both of them. And so we say this. If it is not raining. So this one said it is raining. This one's saying, now we're negating that. Then the streets are not wet.
You just say the streets are dry.
No.
So you just have to use the same words, but with what?
Yes, same thing, but you're going, negate means this. Means make it say what it didn't say up here. Here it said it was raining. Here we say it's not raining. Here it says the streets are wet. Here you say the streets are not wet. Okay, so that's a negation where you take both of them and negate them, make them say what they didn't say before. Now this, folks, there's something I need to put up here so that you can see in the future my abbreviations. This part right here is called the hypothesis, yes, but a lot of times they just call it little p so that they don't have to talk about all of the stuff. We can talk about how it's put together instead. This thing right here, they call little q. And this statement up here, up above, the conditional here could be written, P implies Q. This is the word then. And the word if is understood. They're saying P is true, that implies that Q is true. Now, whether it's true or not, I'm not saying that. Not yet. We're going to talk about truthfulness of things in a few minutes. But this says P implies Q. This one says not P implies not Q. Those are the negations. And the way you write it in words is you make that statement say what it didn't say before. It was raining, now it's not. Streets were wet, now they're not. That's a negation. It's a negated statement. And whether it's true or not is not the issue. And that's going to bother some of you, but I just want you to be able to understand the words and how to negate them, and they may or may not be true, and we're not studying that yet. Okay? So at the top of page 67, they have P and Q, just like I said. And they're just going to talk about a negation, and then they jump right to a core concept. I got a lot more things to show. That's the negation. This is called the converse. The converse switches places with the conclusion and the hypothesis. So we would say this. The converse says, if the streets are wet, then it is raining. So, if this was my original conditional up here and I switch places, then what this says over here is that Q implies P. We reverse where they are, and that's called a converse. This one here and its converse are the most important ones we're going to learn about today. You need to learn about these others too, but these two are the very, very most important. Be able to write a conditional and its converse. Okay? So on this one, this has become, the streets are wet has become the hypothesis. Hence, Q implies P now. We switch places with them. And the last one is a weird name. It's called a contrapositive. And a contrapositive says, do the negation and it takes a converse of the negation. So we're going to negate things and switch things around. So it says this, if the streets are not wet, that's the not part, and I'm reversing it from the conditional. Then it is not raining. Which means that not Q implies not P. We switched them around and negated them. That's all of it all at once. That's the contrapositive. Weird stuff. I agree, but those you got to be able to name all. Taking a conditional, you should be able to write all the other three. So let's consider example 3. It says, let P be, meaning the hypothesis. So the beginning, the conditional, P, you are a guitar player. And let Q be, you are a musician. Write each statement in words and then decide whether it is true or false. Can anybody write using you are a guitar player as the hypothesis and you are a musician as the conclusion? Can anybody tell me what they would write in if then form, just the conditional? If you are a guitar player, then you are a musician. Yeah? Okay. Can anybody write the converse form? Converse, not the negation. I'm not doing them in order. What's the converse of that statement?
If you are a musician.
If you are a musician, then you play guitar. Does that sound right? Just switching the two? Now, it doesn't mean it's true. I just want to know if that's the converse. I'm not asking for truthfulness. I'm just asking you to switch places. So don't get hung up on whether it's true or not. We're just writing them in different ways. So that you're saying that the converse is if you are a musician, then you play guitar. Is that right? Is that the converse?
Yes.
Okay, can anybody write the negation of the original conditional, the negation? Yes.
If you are not a guitar player, then you're not a musician.
If you are not a guitar player, then you are not a musician. That's the negation of the original. Anybody write the contrapositive? Go ahead.
Or if you're not a musician, then you're
If you're not a musician, then you're not a guitar player. Yeah, contrapositive. Okay, so using that hypothesis and conclusion they gave us, you should be able to write all of those things in words. And that's the reason why your exercises are full of words. You have to write all that stuff out. I'm sorry, that's the way it is. You're writing assignment. Okay. I want to talk about this one just a little bit more before we leave it. Do you believe, now we're going to talk about truthfulness. Do you believe that this statement is true?
Yes.
Do you believe that the converse is true?
No.
Can you give me a counterexample?
There were sprinklers.
Sprinklers?
Road.
Could be snowing. The Teton Dam could have broken. Right? Let me make this very clear for those of you who are not really participating with me right here, because you're maybe not sure. If you're asking if a statement is true, you may not question the hypothesis. The streets are wet. You are not allowed to say, well, what if they're dry? No. This is assumed. That's why it's called the hypothesis. This is assumed to be true. Because that's true, does it make this true? And the answer is no. Because it is raining. It's not raining out today. It's not going to rain today. But because I'm assuming it is raining, I'm asking myself, does that make the streets wet? It certainly does, at least after a few minutes, right? Okay, let's talk about the negation. See about that. So it's not raining. Does that mean the streets are not wet? They could be wet, but it's not raining. You cannot question this. But that doesn't necessarily mean the streets are wet. Could be wet for other reasons, just like this failed. Now, think about this one. If the streets are not wet, then it is not raining.
It could be true.
Could it be false? The streets are not wet. They are not. Does that mean it's not raining?
That could be incorrect.
It does, because if it were raining, they'd be wet. The streets are not wet. They are dry. Does that mean it's not raining? Yes, it does. Here's the deal, folks. It's a very interesting kind of thing. If the conditional is true, the contrapositive will be true. If the converse is false, the negation will be false. Same for its truthfulness. If the converse is true, the negation will be true. If the conditional is false, the contrapositive will be false.
So
Something to note.
Is true, false, the contrapositive is true, false.
Right. So if you're wondering if this, because this has got a lot of knots, everything's turned around, you go, I don't know what this is saying. Ask yourself if the original statement is true, because if it is, the contrapositive is. If the converse is true, if you can switch the hypothesis and conclusion, that and if what you have written is true, then the negation will also be true. They're the same truth value, we call it. They go together. Okay, now I want to talk about some geometry statements. I'm going to erase this stuff up here. You can either look at my video or you can take a picture of it before I erase it. I don't know if you want it or not, but it's all here, and I don't know if it'll help you remember things or not. But I'm erasing it. You good? Yeah? Okay. All right. Now we're going to talk about some statements that are made in geometry along these same lines so that you can see how it applies to what we're going to study. So a lot of your exercise is going to be about random weird statements like guitars and musicians and streets that are wet and raining and stuff like that, just to help you practice with these words. But then they're going to, towards the end, they're going to revert to geometry and apply those same skills to a geometric statement. All right. Here is a conditional statement having to do with a definition of perpendicular. Here's what it says. It's not in your book. Not the way I'm writing it anyway, and I'm right, they aren't. They're not completely right. Here's what it says. This is called the definition. I'm gonna write with this marker. It's dead. We say definition, perpendicular lines. That's how we're going to abbreviate it. And it says this: if two lines are perpendicular, I'm going to go ahead and use that upside down T. You have to get used to that because we always take shortcuts. It takes too long to write out perpendicular. Perpendicular. It's 5 syllables. I'm not writing it out. Okay. If two lines are perpendicular, then they, meaning the lines, cross to form right angles. I'm also going to abbreviate angles. Get used to that. It's got that angle symbol. I told you about the angle symbol, right?
Yeah.
Okay. You think this is true? It's the definition of this symbol, or the definition of the word perpendicular. Perpendicular means we got right angles. So most streets are perpendicular. Not all. Most of the ones in Sugar are perpendicular, right? So it says this: if you got two lines and they cross in such a way that the angles formed, all of them are right angles, then the lines are perpendicular. Now, what would the converse of this statement be? If, now, this is the subject, and it shows up, you can't reverse this directly. You can't just take the stuff after then, because you got the word they. What does they refer to? Two lines. So we start out, if two lines again. If two lines what? Cross to form right angles. Then what?
They are perpendicular.
Then they are perpendicular. Do you think that statement is true?
Yes.
Okay. So if the statement, the conditional, and its converse are both true. Here's a huge statement. I'm making an if-then statement. If the conditional statement and its converse are both true, it's called biconditional. And here's another skill that you're going to have to acquire. If you find that a statement and its converse are both true, so it's biconditional, you have to be able to write both of these in a single statement. And here's how it goes. Two lines, the subject of this whole conversation so far. Two lines are, there's your verb in this statement, are perpendicular if and only if they cross to form right angles. This is where your if shows up. And in the future, when you have to write a biconditional, you may abbreviate this part of it this way. All mathematicians know how to read that. They've studied this logic stuff. If and only if can be abbreviated IFF. Now, because it's biconditional, you don't have to start out with the perpendicular and end with the cross to form right angles. You could have started this way and ended this way. Because it's if and only if it reads both directions, it doesn't matter which one you put first. You stick the if and only if in here means that the statement and its conditional, or the statement and its converse are both true. And I'm here to tell you, all definitions in this class, definitions of words, like the definition of complementary, the definition of supplementary, the definition of midpoint, the definition of bisector, the definition of perpendicular, the definition of parallel. Every definition you run into in this class will be biconditional. Okay. Let's see. Oh, wait. Now I'm gonna define linear pair for you. I'm gonna do it with a biconditional. I'm not gonna write these two separately because it's a definition that I'm giving you. It is biconditional, so I'm only gonna give you the biconditional. And it's a lengthy one. See if you understand it. See if you can fill in the spaces when I write this down. Um, the non-shared sides of two adjacent angles form this if and only if, I'm going to use the IFF, if and only if, coming around here, if and only if they form a straight angle. What would go in the blank? A what? The non-shared sides, of two adjacent angles form something. It's the name is what we're defining. If and only if they, meaning these two angles, form a straight angle. What would it be?
A linear pair.
He thinks it's a linear pair. What do you think? Does it make sense to put linear pair in there? Remember, this is what a linear pair is. They form a straight angle. That's the straight angle part, is that these non-shared sides form a straight angle. That's exactly what goes in there. Thank you very much. And you may abbreviate it LNPR, a linear pair, or you put LINPR if you want. That's how I'm going to abbreviate it. Okay, so that's a conditional. It's the definition of linear pair. It's a definition, so it's biconditional. How are we doing so far? Put the phone up, please. Pay attention. Put it away. I want to say it again. Okay, so take a look at example 4. It says, decide whether each statement about the diagram is true. AC is perpendicular to BD. See the little upside down capital T there? AC is perpendicular to BD. Look at the diagram. Do you believe that that's true? Yeah, I'm on page 68. You got to get your eyeballs there because I'm going to draw it on the board. Page 68, example 4. Are you there? See the little diagram over there on the right? Yeah. It says, this statement, we're trying to decide if it's true or false. AC is perpendicular to BD. Do you believe that? Why do you believe that? Yep, because it's marked. If there were no marking there, we could not make that statement, even though it looks like it, right? Okay, next one. AEB. Now find those angles. You all see AEB and CEB are a linear pair. Yes?
Yes.
Because their non-shared sides form straight angle. Okay. And AE, find AE. It's a ray, A that goes through E forever, and EB are opposite rays.
No.
Oh, matter of fact, they form a right angle. They'll be opposite rays, they have to be going in opposite directions. Now, all right. Let's see. I already told you about biconditionals. Let's do example 5. We're going to rewrite the definition of perpendicular. I already did that. Let's go down to monitoring progress and see if you can do the same thing here. Monitoring progress on the bottom of page 69. Are you there, everybody? Looking at them? There's 4 of them to do. So let's take a look. It says, rewrite the definition of right angle as a single biconditional statement. Here is your definition in one direction, with an if-then. It's a conditional statement. It says, if an angle is a right angle, then its measure is 90. You see that that's conditional? The reverse would be what? The converse would be? Not yet, but if an angle measures 90, that is a right angle. Now, can you write that biconditionally, like this? starts out. An angle.
An angle is 90 degrees. Wait,
That's fine.
oh,
Is 90 degrees
it's a right angle.
if and only if
It's a right angle.
it is a right angle. Could we have also written an angle is a right angle if and only if it's 90? That's the way you normally see it, but it could go either way because the statement and its converse are both true. So this is a good way to write it. You could also write it not if. An angle is a right angle if and only if it's 90 degrees. So we could switch those and still have the same thing because it's biconditional. Yeah? Okay. Take a look at the next one. It says, biconditional. Here's the definition. If two line segments have the same length, then they are congruent. That's an if-then statement. Can you write it biconditionally?
Two line segments have the same length, only they are congruent.
Two line segments
Have the same length,
have the same length.
if and only if
I know it takes me a minute. And it will you too. You're going to get tired of this assignment.
they are congruent segments.
If and only if they are, and you can use the symbol congruent. Okay? Does that make sense? We could have said, what else could we have said?
A line segment is congruent only, or if and only if they have, or they are the same.
Same, yeah, and it starts out the same way because line segments is the subject. But we can say what's about them and reverse it. We can say two line segments are congruent if and only if they have the same length. They stays over there. See what I mean? Write it either way. Next one. Rewrite the statement as a single biconditional. Here's a strange one. It's not having to do with geometry. It says, if Mary is in theater class, then she will be in the fall play. They've given you the statement, and then there's a period, and then they've given you the converse. Can you write that as a single biconditional?
Mary is in the.
No if. Not if here.
Mary is in the class, if and only.
Mary is in theater class.
I don't want to.
She will be, if and only if she will be in the play.
If and only if what?
She will be in the play.
She will be in the play. That's weird. Maybe you say if she is in the play.
What if you did like she will be in the play if and only if she's in there?
That works too. Because it's biconditional, it doesn't matter which one comes first. What we're saying here is if she's in the class, she's in the play. If she's in the play, she's in the class. Either way, she's taking the class and in the play. Right? And she has no choice. She's in the class, she's in the play. If she's in the play, then she's in the class. Okay, 13. Rewrite the statement as a single biconditional. Here it is. It says, if you can run for president, then you are at least 35 years old. The converse would be, if you're at least 35 years old, then you can run for president. What's the biconditional? No if, what?
You can run for president if and only if you are at least 35 years old.
Yep. Think you can handle this stuff, you folks? I'm not completely finished yet. Yes, I am. The rest is about truth tables, and they're rough. So I'm not going to teach them to you, nor are they useful to you in the rest of geometry. They're kind of fun if you like logic. A lot of people don't. And it will be useless to you to learn how to do them for the rest of geometry, so I'm not going to teach it to you. You've got a good amount of time today to work on this. I'm not going to be able to give you a lecture tomorrow, so here's what I suggest. I never suggest this, usually. I'm going to turn this off. I'm done with the lecture so that people don't have to hear this when they watch it. See you, bye. But I would suggest